1.5 infinite geometric series. So this is a geometric sum that goes on forever. So in order to show you what happens, let's give you an example. If you save $128 one month, and then save half of that the next month, and then half of that the next month after that, how much would you have saved after 10 months? So we're going to use the formula that we learned yesterday, the SN formula. So it's saying this is my first term, and that is my common ratio. So S10 would be 128 times 1 minus a half to the power of 10 over 1 minus a half. So I'm going to do a little bit of calculator work, and I'm going to figure out what 1 half to the power, 1 subtract 1 half to the power of 10 is, just to show you the intermediate stuff. And I get 1,023 over 1,024, and that is divided by a half. So I end up punching that in, and I get $255.75. Not bad. Okay, so now I'm going to do it for 20 months. So that means I'm finding S20, which is, again, first term is 128. 1 subtract 1 half to the power of 20 divided by 1 minus a half. I'm going to do the calculator work for the bracket part. So 1 subtract 1 half all to the power of 20 would be 128, 104,8575 divided by 104,8576. There's a method to my madness here, you're going to see in a second, divided by a half. So then I get it fills my calculator essentially, 255.9975559, So this is basically approximately $256. Okay, so, and if I were to go, to 100 months later, if you were to punch that in, you would notice that I get 256 as well. Now, why does this happen? Well, what I want you to see here is that this number here and this number here is essentially, the bigger the n is, once you subtract it from 1, you're basically not subtracting much after a certain time. So, and the reason why that happens is you're essentially subtracting nothing from the 1. So, notice that the more terms we add, the closer that 1 minus r to the power n gets to 1. As n gets larger and larger, Sn approaches $256. We say that the series approximates or converges to 256. Does that mean that the sum of every geometric series approaches some limit like that, where basically you are multiplying by 1 for every single time? I'm going to do this next scenario. This time I'm saving $128 and I'm saving double that each month. So double that means r equals 2. Here's my first term again. So the only change that's changing is my r. So S10 equals 128. 1 minus 2 to the power 10 divided by 1 minus 2. If I punch that into my calculator, I get 130,944. If I do it for 20 months, I get 128, 1 minus 2 to the power 20, divided by 1 minus 2, and I get 134,217,600. It's 217,600. So you can see that this is just getting bigger, bigger, bigger. So as n gets larger, what happened there? As n gets larger, the sum gets also larger. The sum does not approach a finite limit, it approaches actually infinity. So this is the first introduction that you would actually see to what we actually talk about all the time in calculus. We say that the series diverges. So if you think of something diverging, it just goes, whoa, you know? So if the absolute value of R, common ratio, is less than 1, in other words, R is a fraction between negative 1 and 1. I mean, it doesn't matter if it's negative or positive, it just has to be between negative 1 and 1. And then n gets bigger and bigger, which means R to the power n basically approaches 0. And the series has an answer to its sum. Otherwise, it doesn't have an answer. You can't add forever. It would be infinity, right? So the way you can tell, again, is that the common ratio is between negative 1 and 1. So here, for example, 3, it says determine which of the following geometric series converges, meaning the sum approaches a limit, or diverges, meaning the sum approaches infinity. So term 1 is 5, and the ratio is 3. So all we have to do is look at the ratio, and that means we cannot figure it out. It's divergent, meaning it's going to infinity. This time term 1 is a fraction, 1/2, but the ratio still is 5. I don't even care about what the first term is. It's the common ratio. So that it means it's still divergent, which means you can't calculate the sum. The sum is going to infinity. For C, the first term is 3, but this time the ratio is 1/3. That means we can calculate the actual sum. And the actual sum is by using this formula, T1 divided by 1 minus R. Now, where the heck am I getting this from? And where I'm getting this from is essentially the formula Sn, except that 1 minus R to the power n is doing nothing to it, so it's basically eliminated, and I'm just left with T1 over 1 minus R. So if I use that formula, again, we can use this formula for any of these sums, but we can't actually calculate it unless there is a limit to the sum, meaning the R has to be between negative 1 and 1. So if I wanted to find the sum to infinity for C, it would be 3 divided by 1 subtract 1/3, which is 3 divided by 2/3, which gives me 9/2. Okay, so let's do some examples then. Find the limit of the sum of an infinite number of terms of the series 5 plus 1 plus 1/5 plus 1/25 plus blah, blah, blah. So the ... indicates it's not ending. It also indicates it's an infinite sum in question. So first term is 5. The common ratio is 1 divided by 5. How do I know that? Because the second term is 1, the first term is 5. The second term divided by the first term gives me the common ratio. So S to infinity would be 5 divided by 1 minus 1/5, which is 5 divided by 4/5, which gives me 25/4. All right, find the sum to infinity for the sequence 1, negative 3/4, 9/16. Again, the first term is 1. The common ratio is the second term divided by the first term. So negative 3/4 divided by 1 is just negative 3/4. So the sum to infinity would be 1 divided by 1 minus negative 3/4, which is 1 divided by 7/4, which is 4/7. All right. Example 6. Find the sum of the following geometric sequences. So 27, 36, 48. So term 1 is 27. The ratio is 36 divided by 27, which reduces to 4/3. So now, if you use the formula, you will get an answer, but the answer is incorrect. The thing you need to notice here is that common ratio is not less than 1, so it's divergent, or the sum is infinity. So what do you say in this case? You could say the sum equals infinity, but you can't get an actual finite answer. So you have to check to see if the ratio is actually between -1 and 1. So term 1 is 3. The common ratio is the second term divided by the third term, so we're good to go because that's less than 1. So the sum to infinity would be 3 divided by 1 minus 2/3, which is 3 divided by 1/3, which gives me 1. All right, so for the following diagram, the largest radius is 8 centimeters. So from here to here is 8 centimeters. Then it's half of that, so that means from here to here is 4 centimeters, etc., etc. So the sum of all circumferences of all the circles. So you have to know that the circumference is 2 pi r. So I need to figure out the first term. The first term is not 8. The first term is the circumference of the first circle. So circumference 1 would be 2 times pi times 8, which gives me 16 pi. Circumference 2 would be 2 times pi times 4, which gives me 8 pi. So that is my first term. And using that, I can get my ratio is 8 pi divided by 16 pi. The pi's cancel, and I get 1/2, which I knew it was 1/2 from the question. So the sum to infinity would be 16 pi divided by 1 minus 1/2. So this would be 16 pi divided by 1/2, which gives me 32 pi centimeters. Then they're wanting the sum of all the area. So again, the first term would be different because the area formula is pi r squared. So area 1 would be pi times 8 squared, which is 64 pi. Area 2 would be pi times 4 squared, which is 16 pi. So here is term 1. Term 2 will give me the ratio, which is 16 pi divided by 64 pi, which the pi's cancel, and I get 1/4 as my ratio. So the sum to infinity then would be the first term, which is 64 pi divided by 1 minus 1/4, which is 64 pi divided by 3/4. So if you're having a problem knowing how I'm punching this in my calculator, I'm essentially leaving the pi alone, and I'm just punching in 64 divided by 3/4, and that's how I'm getting 256 over 3 pi centimeters squared. Centimeters squared because it's area. And for the last question, really cool question if you ask me, is do you ever think of how you can figure out what a repeating decimal is as a fraction? Well, I'm going to show you. It actually has to do with infinite geometric series. So 0.63 repeating means it's 0.63, 63, 63, 63. Does everybody understand that? Which means it is 0.63 plus 0.0063 plus yada, yada, yada. So my first term would be 0.63. My second term gives me the common ratio, which would be 0.0063 divided by 0.063, which gives me 0.01. So the sum to infinity would be 0.63 divided by 1 minus 0.01, which gives me 0.63 divided by 0.99. I don't know if you've ever seen this before, but 0.63 over 0.99 is the same thing as a fraction of 63 over 99, which reduces to 7/11. 7/11. And check on your calculator. If you go 7 divided by 11, you will get 0.63 repeated.